Today's video is a review video on greatest common factor and least common multiple. So what you want to try to do is pause the video and try the practice problems on your own first before you watch me solve them out for you. This way you can determine what you're doing well with and what you may need to work on. Here are a few practice problems for greatest common factor, so let's pause the video and try the practice problems on your own first. Okay, let's go over the first one. We have 27 and 63, so we're going to start by building our cake. You always want to start with, can I divide them both by 2? I can't divide them both by 2, so then you go to the next prime number, which is 3. Can I divide them both by 3? And for these two numbers, I can. So I'm going to put a 3 on the outside of the cake. 27 divided by 3 would be 9. 63 divided by 3 would be 21. Look at the two numbers and decide if there's another prime number you could divide both of them by. We can't divide by 2 because neither of them are even, but we can divide both of them by 3. So we have 9 divided by 3 is 3. 21 divided by 3 is 7. So we have 3 and 7 left over in our cake. There's no prime number that we could divide both of them by, so that's how we know we're done with our cake. For greatest common factor, you look at the outside. And we have two layers, two numbers, 3 and 3. You take the two numbers and you multiply them. So we have 3 times 3 equals 9. So the greatest common factor of the numbers 27 and 63 is 9. Okay, so the second one was 54 and 12. So we start our cake. And then we try to decide which prime number we can divide both of the numbers by. So I always start with 2. Can I divide both of these numbers by the prime number 2? And I can because they're both even. So 54 divided by 2 would be 27. 12 divided by 2 would be 6. So I look at 27 and 6 and I try to decide if there's another prime number I could divide both of them by. And I can't do 2 because 27 is not even. But I can do 3, so I'm going to make another layer of my cake, and I'm going to divide by 3. 27 divided by 3 gives me 9, and 6 divided by 3 gives me 2. So now I have 9 and 2. There's not another prime number I could divide both of them by, so that's how I know I'm done. Look at the numbers on the outside of your cake, so we have two layers, so we have two numbers, and you multiply them. 2 times 3 equals 6. So our greatest common factor of the numbers 54 and 12 would be 6. So now I have 88 and 66, and I want to find the greatest common factor of these two numbers. So I'm going to build my cake. And I need to choose a prime number that I can divide both of them by. So looking at 88 and 66, I can see that I can divide them both by the number 11. Put 11 on the outside of my cake. 88 divided by 11 is 8. 66 divided by 11 is 6. Now remember, if you chose to start your prime factorization with a different prime number besides 11, then you're still going to get the same answer that I do in the end. So now I have 8 and 6, and I'm going to divide them again. So build another layer of my cake. I could divide both of them by 2. 8 divided by 2 is 4. 6 divided by 2 is 3. So now I have 4 and 3 left over, and there's not a prime number that I can divide both of them by. So I'm finished. So I'll look at the outside of my cake. I have two layers, 11 and 2, so you multiply them. 11 times 2 equals 22. So my greatest common factor of 88 and 66 is 22. Okay, so here's our last practice problem for greatest common factor. We have 80 and 66. We're going to start to build our cake. I always start with 2, so can I divide them both by 2? And for this one I can because they're both even. So I put a 2 on the outside. 80 divided by 2 gives me 40. 16 divided by 2 is 8. So 40 and 8, since they're both even, I know I can divide by 2 again. So build another layer of my cake. Put a 2 on the outside because I'm dividing by 2. 40 divided by 2 is 20. 8 divided by 2 is 4. Again, both of the numbers are even, so I know I can divide by 2. So build another layer of the cake. Put a 2 on the outside. 20 divided by 2 is 10. 4 divided by 2 is 2. And again, we have 2 more prime numbers, so we're going to divide by 2 one more time. Build another layer of our cake. Put a 2 on the outside. 10 divided by 2 is 5. 2 divided by 2 is 1. 5 and 1, there's no other prime number I can divide both of them by, so I'm finished. I look at the outside numbers of my cake. There's 4 different layers, so we should have 4 different numbers, and you multiply them together. So I have 2 times 2 times 2 times 2 equals 2 times 2 is 4, times 2 is 8, times the last 2 would give us 16. So the greatest common factor of 80 and 16 is 16. So now we're going to do some practice problems with least common multiple. I want you to pause the video, and then when you finish, you can press play and we'll review through your answers. Okay, so let's go over the first example. We had 15 and 6. Just like greatest common factor, we're going to build our cake with least common multiple, so start your cake. You want to be able to divide both of them by the same prime number, so 15 and 6. Can I divide them by 2? And I can't because 15 is not even. Can I divide them both by 3? And I can. So I'm going to put a 3 on the outside of the cake. 15 divided by 3 gives me 5. 6 divided by 3 gives me 2. So now I have 5 and 2 on my cake, and there's not another prime number I could divide both of them by, so I'm finished. So now the one step that's different from greatest common factor is with least common multiple, we build the L to solve. So make your L, and then you multiply them together. So we have 3 times 5 times 2. 3 times 5 is 15, times 2 is 30. So the least common multiple of 15 and 6 would be 30. Okay, so the second example, we have 18 and 15. We're looking for the least common multiple, so we're going to build our cake. We need to decide on a prime number we could divide both of them by. For this one, we can't choose 2 because 15 is not even, but we can choose 3 because you can divide both of them by 3. So put a 3 on the outside of your cake. 18 divided by 3 gives me 6. 15 divided by 3 gives me 5. So now I have 6 and 5, and there's not another prime number I could divide both of them by, so I'm finished. And the difference with least common multiple, a way to remember it is the L for least. You build the L, and then you multiply them together. So we have 3 times 6 times 5. 3 times 6 is 18. 18 times 5 would give you, let's do the work on the side, 5 times 8 is 40. 5 times 1 is 5, plus 4 is 9, so 90. Our least common multiple of 18 and 15 is 90. Now we have 25 and 35, and we're looking for the least common multiple. So we build our cake. 25 and 35. The first prime number I can divide both of them by would be 5. So put a 5 on the outside. 25 divided by 5 is 5. 35 divided by 5 is 7. So now I have 5 and 7 in my cake, and there's not another prime number I could divide both of them by, so I'm done. Since we're doing least common multiple, remember the L. We have to make the L in our cake, and then multiply together. So we have 5 times 5 times 7. 5 times 5 is 25. Times 7 is, we'll do our work on the side, 25 times 7. 7 times 5 is 35. 7 times 2 is 14, plus 3 is 15, 16, 17. So 175. So our least common multiple of 25 and 35 is 175. Okay, so now we have our last practice problem for least common multiple. We have 28 and 70. So I'm going to start my cake. I could divide both of them by 2. "28 divided by 2 is 14. 70 divided by 2 is 35. Okay, so I'm going to make another layer of my cake. We need to decide on a prime number you could divide both 14 and 35 by, and they're both divisible by 7. So put a 7 on the outside of my cake. 14 divided by 7 is 2. 35 divided by 7 is 5. Since there's no prime number I can divide both 2 and 5 by, I'm done. So since we're doing least common multiple, remember the L. We're going to make our L, and then multiply all the numbers together. So we have 2 times 7 times 2 times 5. 2 times 7 is 14, times 2 is 28, times 5. We'll do our workout on the side. 8 times 5 is 40. 5 times 2 is 10, plus 4 is 14. Equals 140. So the least common multiple of 28 and 70 would be 40. Now I want you to pause the video and try these 3 practice problems on your own. These questions involve 3 numbers for greatest common factor, so remember that you have to be able to divide all 3 numbers by the same prime number. Okay, let's go over the first one. We have 18, 30, and 27, and we're looking for the greatest common factor. Start your cake. I could divide all 3 numbers by the number 3. Put a 3 on the outside. 18 divided by 3 is 6. 30 divided by 3 is 10. And 27 divided by 3 would be 9. So now I have 6, 10, and 9. And there's not a prime number I could divide all 3 numbers by, so that means I'm finished. Look at the outside layer of my cake. I only have 1 layer, and it's the number 3. So the greatest common factor of 18, 30, and 27 would be 3. That's the largest number you could divide all 3 numbers by. Okay, let's try the second one. So I'm going to start my cake. The prime number I could divide all 3 of these numbers by is 3, so I'm going to put a 3 on the outside. 27 divided by 3 is 9. 63 divided by 3 is 21. And 54 divided by 3. Let's do our work on this side for that one. 54 divided by 3. 3 goes into 5 one time. Bring down the 4. 3 goes into 24 8 times, which is 24. Okay, so 18. So now I have 9, 21, and 18. I could divide all 3 of these numbers by the number 3 again. So put a 3 on the outside. We'll get rid of this work over here. So 9 divided by 3 is 3. 21 divided by 3 is 7. And 18 divided by 3 is 6. So now I have 3, 7, and 6, and there's not a prime number I could divide all 3 of those by. So I'm finished. I have 2 layers of my cake. So you take the 2 layers and you multiply them together, so it's 3 and 3. 3 times 3 equals 9. So my greatest common factor of 27, 63, and 54 is 9. Okay, here's our last practice problem for greatest common factor with 3 numbers. I'm going to start my cake. I could divide all 3 of these numbers by the prime number 2. So put a 2 on the outside. 6 divided by 2 is 3. 12 divided by 2 is 6. And 18 divided by 2 is 9. Now I have 3, 6, and 9, and I could divide all three of these numbers by the number 3. So put a 3 on the outside. 3 divided by 3 is 1. 6 divided by 3 is 2. And 9 divided by 3 is 3. I have the numbers 1, 2, and 3, and there's not a prime number I can divide all three of them by, so I'm finished. I have 2 layers of my cake, so I need to multiply them. 2 times 3 equals 6. So the greatest common factor of 6, 12, and 18 is 6. Now pause the video and try these practice problems for least common multiple with 3 numbers. Now remember, you need to be able to divide at least 2 of the numbers. So it's different than greatest common factor because you don't need to be able to divide all 3, but you have to be able to divide at least 2 of them by the same prime number. Okay, let's go over the first one. So we'll start our cake. I have 4, 24, and 21. I could divide at least 2 of them by the prime number 2. So I'm going to put that on the outside of my cake. 4 divided by 2 is 2. 24 divided by 2 is 12. And 21 I can't divide by 2, so since I can't do anything to it, I have to keep it 21. Okay, so I'm going to build another layer of my cake. I have to be able to divide at least 2 of the numbers by the same prime number, so I'm going to go with 2 again. 2 divided by 2 is 1. 12 divided by 2 is 6. And 21, again, I can't divide it by 2, so since I can't do anything to it, I have to keep it 21. So now I'm going to build another layer of my cake, and I could divide at least 2 of them by the number 3. So 1 divided by 3, I can't do it, so I'm going to keep it 1 since I can't do anything to it. 6 divided by 3 is 2. 21 divided by 3 is 7. Now I have 1, 2, and 7, and there's not a prime number that I can divide at least 2 of them by. So since it's least common multiple, remember the L, we're going to build our L. And then multiply all the numbers that fall inside our L. So I have 2 times 2 times 3 times 1 times 2 times 7. 2 times 2 is 4, times 3 is 12, times 1 is 12, times 2 is 24, times 7 is, let's do our work up here, 24 times 7. 4 times 7 is 28. 7 times 2 is 14, plus 2 is 15, 16, so 16, so 168. So our least common multiple for 4, 24, and 21 is 168. Okay, let's try the next example. We have 14, 15, and 18. We're going to build our cake. Since it's least common multiple, we have to be able to divide at least 2 of them. So remember, least common multiple, at least 2. So we can divide at least 2 of them by the number 2. So 14 divided by 2 is 7. 15 we can't divide by 2, so we have to keep it 15 since we couldn't do anything to it. And 18 divided by 2 is 9. So now I have 7, 15, and 9. And I could divide at least 2 of them by the number 3. 7 I can't divide by 3, so since I can't do anything to it, I have to keep it the same, 7. 15 divided by 3 is 5, and 9 divided by 3 is 3. 7, 5, and 3. There's not a prime number that I can divide at least 2 of them by, so now I'm going to make my L for least common multiple. After you build your L, you multiply all the numbers inside of it. So I have 2 times 3 times 7 times 5 times 3. 2 times 3 is 6, times 7 is 42, times 5, do our work on the side, 42 times 5. 5 times 2 is 10. 5 times 4 is 20, plus 1 is 21, so 210. Times the last number, 3. Do our work on the side. 210 times 3. 3 times 0 is 0. 3 times 1 is 3, and 3 times 2 is 6, so 630. So the least common multiple of 14, 15, and 18 is 630. Okay, so now we have our last practice problem of the video. We're looking for the least common multiple of 86, 68, and 20. I need to be able to divide at least 2 of them by the same prime number, so I'm going to start with 2. And I can actually divide all 3 of them by the number 2. So 86 divided by 2 would be 43. 68 divided by 2 would be 34. And 20 divided by 2 is 10. I'm going to build another layer of my cake. I can divide at least 2 of them by the number 2. 43 I cannot divide by 2, so I'm going to keep it 43 because I couldn't do anything to it. 34 divided by 2 is 17. And 10 divided by 2 is 5. Now I have 43, 17, and 5, which are all prime numbers, and I can't divide them all by the same prime number, so I'm finished. I'm going to make my L for least common multiple. Remember your L. After you build your L, you multiply all the numbers together. So now we have 2 times 2 times 43 times 17 times 5. So this is going to be a big number. 2 times 2 is 4 times 43. 43 times 4. 4 times 3 is 12. 4 times 4 is 16 plus 1 is 17. So that's 172. So now we have 172 times 17. Seven times 2 is 14. 7 times 7 is 49, plus 1 is 50. Put down the 0, carry the 5. 7 times 1 is 7, plus 5 would be 12. Put a 0 to hold your place. 1 times 2 is 2. 1 times 7 is 7, and 1 times 1 is 1. When you add it all up, we have 4, 2, 9, and 2. So that equals 2,924. Then the last number times 5. Five times 4 is 20. 5 times 2 is 10, plus 2 is 12. 5 times 9 is 45, plus 1 is 46. And then 5 times 2 is 10, plus 4 is 14. So the least common multiple of these 3 numbers would be 14,620. Now that's the end of our review video. I hope you found this review video helpful. And remember, you can always rewatch it and try the practice problems again.